Let's just say that the scores were normally distributed. The mean was 8 and standard deviation was 2. So in other words, the scores were normally distributed. So the variable here would be exam scores. They're normally distributed with a mean of 8 and standard deviation 2. Well, to use the empirical rule here, what we're going to do is calculate the mean plus 1, mean plus 2, and so on. And that's what we're doing here. Right? That's what we're doing here. Within one standard deviation to the right and to the left of the mean, or greater than the mean and less than the mean. So the mean plus 1 standard deviation, right? That's 8 plus 2, which is 10. Whereas here, we have 2 standard deviations. So we're at the mean, and we add 2 standard deviations, which is 2 times 2. We get 12. Standard deviation is 2. If we were to subtract a standard deviation, we have 8 minus 2, which is 6. 8 minus 2 times 2, which is 4. So 8 minus 4 is 4. And then if you do 8 plus 3 standard deviations, which is 6, you get 14. 8 minus 3 standard deviations is 2. Now for the empirical rule, it's telling us that 68% of the data, that is 68% of the scores, okay, they are between 10 and 6. Let me draw it actually. Hopefully this will work, but we will see. 68% of the data is between 6 and 10. So 68% of the scores, or 68% of the students, that's better, scored between 6 and 10. Okay. And this is also saying about 95% scored between a 12 and 4. So 95% scored between 4 and 12. So this is including this part. So all this accounts for 95% of the students. And then finally, if we keep going, from 2 out here to 14, almost all the students, 99.7%, scored between a 2 and 14. So the exam is at a 15, right? And 99.7%, almost the entire class, scored between a 2 and a 14. So I'm not saying some students didn't get a 0 or a 15. It's just that very few of them did. I mean, the exact amount, I think, would have to be, depending on how many students there are, of course. So, all right, let me see. I mean, that's just a basic demonstration with the empirical rule. So are there any questions about this? Just erase this. But again, so what this is saying is the further away, well, a consequence of this actually, the further away you get from the mean in either direction, okay, the less frequent the score becomes, the more rare it becomes, or the rarer. That's really what this is saying. And this is what they call the empirical rule. I'm not sure if other distributions have this property. They might, I just don't know. I don't want to go too far past this, but I mean, this is just really another example. It's really the same idea. So suppose now we had a normal distribution with a mean of 34 and a standard deviation of 0.5. Okay, I mean, if you were to draw that, you could try drawing that. Let me go back to Desmos. Let me see. Let me share that though. So I think I said the mean is 34. Oh, wait, it's not going to show up here. All right. Well, oh, that's all right. But again, you know it's going to have this kind of shape, though, as you can see on there. I mean, if the standard deviation we made at 0.5. Okay, that didn't work. Let me see if I can. Yeah, I can't get that on this. But it's going to look something like this. You know, it's going to look something like this. Okay. Let me get back to the notes. Here we go. Again, we can use the empirical rule to see where most of the data is. You know, so for instance, if it's 34, the standard deviation is 0.5, then 68% of the data is between 34 minus a half, which is 33.5, and 34 plus a half, which is 34 plus 0.5. Here, 95% of the data is between 34 minus 2.5, 2 times 0.5. Okay, so again, we're going 2 standard deviations away from the mean. Less than it and greater than it. 95% of the data is within these bounds. Okay, yeah, let me show that textbook thing again. And of course, I closed it. Figures. Actually, let me see if I can get. I'll look at it next time. So that's what this thing is saying then, okay? You know, if you go between the mean minus the standard deviation and the mean plus the standard deviation, okay? 68% of the data is within those two, between 2 standard deviations away, so 34 minus 2 times 0.5, and 34 plus 2.5, 2 times 0.5, so you're going within 2 standard deviations away from the left or right. That's 95% of the data. So for this one, 95% of our data is between 34 and 35. And 99.7 is between 34 minus 3 times 0.5, 3 standard deviations away. 34 plus 3.5, that's 35.5. So that's just what the empirical rule is telling us. Now, I don't know if I drew a graph, but let me double check. Oh, I didn't. Okay, but I think we should stop here because I don't want to get too far away from the class, ahead of the other class, I mean. So